نظرك الأحسن فيلوشيب ولا اسيستنت ولا يعني ولا اشتراك؟ لو الواحد في حاجة نيو انتجريشن.
هنبدأ. The last week we have started with designing data collection tools, and this time we should revise what we have started with and have an introduction to data collection. If you already started on DataCamp, then you have taken a good shot there. I hope that this information will add to what you have started learning. The aims of today is first to start understanding the statistical terms in publications and get accustomed to what is used in publications, and also start using them to represent your own data. So first, what is data again?
Generally?
Yeah, what is data?
Information.
Information.
Data can represent different types of information.
Can represent different types of information.
Like it could be something quantifiable or I don't.
Ahmed, what's your opinion?
The same thing. That would be some sort of information or not information, but I don't know the right definition.
I'm not looking for a definition, but data is everything around us. The light intensity is a source of data. The number of chairs here is considered part of the data around us. The representation of anything around us in numbers are considered data. And the data are not information. Information is something processed. So we say information is processed data. So for example, petrol is not yet processed, but gasoline is a processed form of petrol. And also information is a processed form of data. We have raw numbers, and we need to transfer them into meaningful, usable information, so we can bend decisions later on based on them. Okay, and then the next level of, or the third level of information, or after that, is wisdom. So what can be implicated, or what can we deduce from the data to make something that we can, or we can something that is not based on available data. So the wisdom is something that we build not on the available data, but on our experience. Okay? So where is data?
Everywhere.
exactly. So it is everywhere. Everywhere we can get data. For your example, where are the data in your field?
And patient files.
In the patient files. You are a physician, then it should be in the patient files. Where else?
Um, mm, and my field in the radiology, I will find the data in the machine.
The machine. Good. This is a very important source of data. So you have spotted one of the important sources of data in your field. The machines themselves are producing lots of data, log files inside the machine, metadata that are attached to the pictures. So you have the picture, the DICOM photo, and within the DICOM photo there are also hundreds of metadata fields that are attached to this picture. For example, you can find the settings of the machine, the information about the electricity, information about the intensity of certain measurements or intensity of certain setup in the computer. You can find also data about the patient imported from the medical records or added by the operator of the machine. What else? Where else you can find data?
Where else?
Try to help Muhammad also to find the data in his environment. Because Muhammad is lacking now a source of data for his project. So where can we find data for him?
In the archive.
Archives? It is also medical data.
Yes.
Yeah, but there are also other types of data in your environment that you can use for your future project.
Okay.
You can build a new innovative project from the data around you, but from sources that you didn't think about.
Okay. The location, perhaps, where
The location of?
where we live or where the hospital is.
Okay, but this is a constant.
Okay.
There are different types, and we will see this. Your hospital in this in your experiment is a constant. If you will add another hospital, then this variable it will be converted into a variable. So you can compare two hospitals based on this variable they cite. But if you are within a hospital, then within one hospital, then this is a constant.
Okay.
A constant. This is something outside our experiment. We cannot change it. Then we will not use it.
Can be a variable for the patient. I mean, how far are the patients from?
So the patient origin or the patient habitat or the patient address.
Yeah.
Okay, so this can be considered a variable. Okay, this is so this can affect the patient disease status, for example, or the response to treatment or something like this. So their adherence to treatment, or it can affect their follow-up visits. If they are coming from long distances, then it can be considered a variable. Yeah, right?
Communication methods, perhaps.
Communication methods, what do you mean?
I mean, perhaps how the patients come to the hospital with the ambulance or with the helicopter or with their...
Yeah, this is exactly something that we can consider in our experiments or in your situation, because some of the patients can come with slow mobility options, and this can affect their results, especially in the critical care
Yes.
units or the emergencies. And also, one of my studies previously were depending on such thing, but in low resource setup, where the option is to come using multiple transportation methods, which people cannot afford, or through long distances, or to come with a train and take one or two. If the patients are using only one transportation method or multiple transportation methods, that can make things difficult for them. Okay, so this can be a variable. What else?
Personal, perhaps.
So the patient itself, the patient himself can be a field of data or variables. The shield or the environment around the patient or between the patient and the hospital. Okay?
Yeah.
What else can be?
The hospital team.
The hospital team themselves, okay?
The education of the hospital.
Okay, so you are thinking now about the training?
The training.
The training of the staff, the training physicians or supporting team can be a source for variables or source for data.
Yes. The equipment in the hospital. Yeah.
Okay.
Could be
The equipment, you mean the available
technique or equipment. I mean.
The technique is something for training, and the equipment are something for setup.
The equipment, I mean, if the all required instruments are available or not.
Okay, so also you can consider the patients themselves as source of data, the patient's opinion, the patient's beliefs can be source for lots of variables. The setup can be also something else other than the medical setup. It can be the chairs that the radiologists are sitting on. Are they comfortable for them or not? So and the timing they are. So you can, for example, check the timing of how many hours the physicians are sitting on specific chair and compare different chairs and the effect on the decision they take. Okay, so actually there are lots of variables that the experimenter can use during his experiments, his building or his time while he is doing or thinking about an idea. Once I was looking for, one time I was asking my daughter if we can do an experiment in our house, and she said, what does it mean? I was trying to introduce her to the idea about the research. So I told her we have many things in our phones that we can use for experimentation. So I introduced her to some of the Google tools on the phone. And using your phone, you can check the intensity of light. And if you can compare it in different places, in different rooms, and so on. And you can also compare the sound intensity by decibel in each part of the apartment, and you can also stand yourself in a place in the apartment and rate your satisfaction about your comfort in this place. Okay, from 0 to 10, for example. and build a spreadsheet that say in this corner of the home there is this intensity of light, this intensity of sound, and I feel this comfort. And by repeating this in each corner of the home, then correlating this or building a chart using this table, you will have, for example, an idea which place you would like to sit or sit down in if you have something to think about or if you want to be more comfortable. Okay, so yeah, this is how research idea can start from. So the data is everywhere. Don't limit yourself with the data you are used to, and also don't limit your hypothesis and idea with certain predefined limits.
This is creative.
Okay.
Okay.
So this is also what we tried to use in the first or the second presentation when I showed you the desert.
Yeah.
So it is something like this also. Sources of data. So we mentioned sources of data that are coming from machines, that sources that we can use our phones to get, sources that we get from registers, I mean from the logbooks of, for example, the entry logbooks of certain place. These are also data that we can collect. So the first source of data is something that we can go and collect actively. We can disseminate a survey and take opinions. We can dig deep in the electronic medical records or the regular medical records and start finding the elements that we defined in our protocol. So if you attended or you have watched the protocol building or protocol writing session, you will find that we define case report forms that will look for specific items that will fulfill our answer and over milestones. And by going to the medical records at these milestones and start looking for these data in the medical records and filling our case report forms, then you can follow up on these data. You can fulfill your case report forms. One of the most important points in the clinical research is that the physicians who are conducting the clinical trials should be oriented or conducting the delivery of medications and treatment of patients and follow-up of patients should be very oriented with the clinical trial they are enrolling the patients on. Okay, so if the patient is coming and then being diagnosed and examined, the person who is taking the notes should be oriented with which notes he should write in the medical records, because somebody else will come after him and start taking this information from the notes he has taken. Okay? The physicians are not filling the case report forms for the clinical trials. This is the norm. Most of the times, a clinical research associate will come later and start picking the data from the medical records. Sometimes the clinical research team asks the physician to fill in the case report form himself as a follow-up documentation, a follow-up sheet for the patient, and this will facilitate the clinical research process But some physicians find it tedious, find it not easy to fill in a full case report form for each patient that he sees, and say, okay, I just need to write that the patient is normal, that's it, and I don't need to fill 2 or 3 pages to say the patient is normal. Okay? So, in clinical research, we need to explicitly say that this finding is not there, this finding is there, this finding is not there, and so on. Okay? Do you understand this point? Because this is a very important point in clinical research. And this is the fight between clinical researchers and the physicians inside any clinical research experiment. So this is the collect process. One of the things that I've shown you last time how to create case report forms. Today, I just need to make one simple task for this. What is the next thing you want to buy in your list, on your list? Just if you are going today to the supermarket and will buy something, what's the next thing you will buy?
This will be a task.
Hmm?
Is this a task or a question?
This will be the task of the next 10 minutes.
And a request form or how should
What is the next thing you want to buy today if the supermarket is open and you are free to go?
Bread and hummus.
Okay, so bread. So we will need to collect the price and the names and the content of Lidl breads, types of bread for you. What's for you?
something easier?
So you will start collecting data about the types of bread in Lidl.
No.
Hmm? Yeah, this is the task now.
Okay, meat.
Meat. Okay, what kind of meat?
What
do you
kind of
expect?
meat? Rent. Cool. Rent flesh. Meat.
Okay, and how do you define the
How to define?
quality of meat?
Like quality. I go to the shop and I look what they have, the small one or a big one, a small coup or a big coup.
Okay, so we can now check for Berlin Mitte, which are the places that sell meat and their prices and the types of meat they offer.
Okay.
Okay, and we will make this in an Excel sheet.
An Excel sheet.
Yep.
Okay.
So don't go beyond 10177 as Postleitzahl.
Okay. 10177.
Yeah, this is our Postleitzahl.
Yep.
You can go to Amazon Fresh if you have a problem with finding places in 1077 to find. I mean 10177 to find places for that.
Okay.
I think it's 11.7 or
11,
17. Sorry, yeah. 10, 11, 7.
Amazon Fresh. We learn here not only clinical research but how to find food. Amazon.
They don't sell bread online.
Really? Then 11, 7. Okay, they have a prospect, but it is not for comparing. Online shop in Djibouti
How many items at least should I?
for each
For comparing how many?
just 2, 3.
Then maybe I can change it to Blumen.
Okay. So the color,
Blumenstrauß.
the color and the what else? The color, price, and what else?
Type.
Type, color,
Color.
price.
Mm,
Okay.
price.
They have bloom in here. Little bloom. جبنا في كام؟ لقيت حاجة؟
لا ممكن نشتري سمارت أحسن. مش كده المفروض هناك دلوقتي اسم الماركت هنا وبعدين نوع السمك الوزن والسعر، مش كده برضه ولا إيه؟
ماشي. بس هو يعني
حضرتك
احنا
عايزين كام فاليو؟
2 3 مش أكتر.
كفاية قشطة.
خلاص؟ طيب كويس. كوانتيتي 10 وردات يعني، والسعر 17. نوع ايه بقى ولا مش؟
الصراحة أنا ما عملتش علامات ولا
مم.
بس عملتهم بالكالرز يعني.
اوكي. بس ما فيش مش نوع. طيب مش مشكلة يعني مش قضية.
ممكن أحاول ممكن ألف أنواع عادي.
اوكي. ولهذا في مثل هذا
إيه بيجيبوا إيه؟
في حاجة في مثل هذا
او يعني عشان كده يعني في عشان الحيرة ديت ار ستوديو او ار عاملين لنا حاجة لطيفة عشان الناس اللي محتارة.
زينا كده.
هو نشاط يعني زي ده ممكن نعمله عن طريق ان احنا ننترفيو بعض، بس هو مفيش غير 2.
كورس كلينيكال ريسيرش ولا بتعمل Einkaufen؟
This should help يعني. يعني المفروض الكورس يبقى مساعد على الحياة برضه.
Yeah. Interesting.
The day-to-day life tasks.
Yeah, yeah. Okay, somehow it looks not to be.
تترينجر
Next one, you know, someone send the blue page.
مغريات بالمنظر ده إن شاء الله.
Okay, are you finished with data collection? What are the variables of the fish database or big fish database?
The fish type, market, weight, and price.
Okay, I believe this is a good data set for building a decision. Okay, and your database data set, Asma?
Flower type, color, quantity, and price.
Okay, so this can help you to decide what? From-
Decide what?
This is the question. To decide?
Based on the quantity and price.
The quantity and price. Based on the quantity you will, and the price, you can define or define the most appropriate for your budget.
Yes.
Okay.
Cost benefit ratio.
And Muhammad,
Cost benefit ratio.
your
Quantity and the price too.
okay, and also for your decision, it will also help you to define which market, right?
Which market to go?
To go. Okay, because you already added a variable for the market.
Yes.
Okay, so this should be a nice data set. So the second, so you have now collected the data yourself. You have done what we call scrapping of website or different websites. This is a source of data collection. You can do the scrapping by hand, but what you have done now by hand, there are softwares that can do for you. And if you search the internet for web scrapping, you will find tons of software packages that can collect these prices, markets, and all the information if you trained these softwares well. Okay, it will save you time. So what you have done for collecting 10 or 20 items in your dataset can be enough for collecting thousands of items by the web scrappers.
Web scrub. Okay.
Yeah, they are called web scrappers.
Okay.
I use the web scrubbers to collect information about physicians in certain areas or supermarkets or information, contact information for different people from, for example, Yellow Pages, Gelbe Seiten, or something like this here in Germany, or from the telephone book. Telephone book here in Germany, you can collect also information about all the available physicians in certain area, what are the specialties that are available in certain place, so you can decide also if you will go to this market or not. Okay?
Yeah.
The other source of data is the open data. Experiments are encouraged, all the scientists are encouraged to publish their own data to show that the data are, or their experiments are open, are transparent, and this should give reputation to their science and show that this is a real science, not a fake, not a fake science. Okay. So if you go to the internet and search for open and then your field, for example, your open radiology dataset, check online for open radiology or open neuroradiology dataset. Should be able to find multiple datasets that can help you. Actually, you can use these datasets according to the rights. If there is an attached copyrights information to them, you can read it and check if you can use this data later on. Because normally you can use the data available on the internet to do further analysis on them.
Okay.
So, did you find something?
List of open access medical imaging dataset, NIH Clinical Center release dataset.
Okay, 32,000 CT images. Okay, so all these open access medical imaging datasets are available. You can use them for your experiments, and usually there are, not usually, sometimes there are attached clinical data to these datasets. So, for example, you can find the patient disease, the medical condition, different lab results, and some elements that can help you in classifying these patients. Okay? In my master's degree, I used a clinical dataset of retinoblastoma patients and dataset for a neuroblastoma, one for ovarian cancer and one for colon cancer. And all these datasets had an attached staging and patient age clinical data. So besides some other information about the tumor and the patient, that I could use then for the classification, and I used this to develop my thesis. And actually, the focus of my thesis was to develop a new algorithm for classifying the patients based on their gene expression data. Okay, and I was successful to find such datasets and use it. Although these tumors are not that, for the retinoblastoma and neuroblastoma are not that frequent.
Yeah.
So especially retinoblastoma is a very rare tumor.
Yeah.
So to find such dataset is something nice. Okay, did you find something?
I don't know. It was here.
Yeah, you can you open the last page?
Last page. Yes.
Okay, so when you open such page, go down. Down. So here is the dataset. You can download the dataset itself.
This
From,
one.
yeah, from these pages. You have to accustom yourself with the type of data. You have to live some time with the data. Know where are the variables, which variables are available, which variables are available in another metadata. So metadata is something about the data. So if you have a data that is about, for example, CT, metadata is something about these data. So if you have a photo for a patient, you have his CT of the brain of this date.
Yeah.
The metadata of this patient can be a text file that describes this photo, includes the stage of the disease, the age, the date of this picture, or the year of this picture, or the milestone, the treatment that he had, also the any other clinical information about this patient. Okay? So usually look for the data and check also if this data had a metadata. Okay? The first look can be sometimes, exactly, can be confusing.
Yeah.
So take your time,
Yeah.
live with the data. Ask also the data provider if he can give you some help about the data, if certain files have specific information that you need to open first before you open the data itself. So because others develop this data, so you have to take time understanding it.
Yeah.
Okay? There are thousands of resources now for open data, and it needs a new hypothesis, a new idea for you, a new statement for you that you go and examine within these open data files. Closed data is data that are developed within clinical trials, but they are not accessible on the internet or within any experiment. Sometimes you can access these data by writing an agreement with institutes. According to their flexibility, they can give you an access. Sometimes they ask for co-authorship or to write a collaboration with them to access this data. So also don't when you read a clinical trial, a paper about clinical trial, ask if you are interested in doing further ideas or examining further ideas for these patients. You can simply ask the first author, is the data available, or the correspondence author of the paper. Ask if the data can be used for, or can you collaborate with them within their data. It will not be easy, but ask, because it is sometimes available.
Okay.
And then why we need statistics? So statistics is just not, it is not just the tool we do for research. If you know G. Wells says statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write. So it is the ability also to understand how to convert what you see, what your observations of the world around you into ideas. So it is not anymore a luxury. It is the ability of you to think logically. Okay? So this is the should be one single important skill for the future. Another term we need to understand is the population and the sample. What is a population? Give me an example of a population for your data set you have built now.
The patient who
Yeah,
has-
the data set you have built from the internet now.
My population are the market in the region here who have fish to buy or to sell. I think.
Okay, so the population is all the markets, not on the market, but all these fish types in all the markets in the region you can access here in Berlin.
Yes.
Okay, so all fish types in all markets in Berlin that you can access at the moment.
Everything with fish at first. Fish.
Fish,
Everywhere.
fish in all markets that you can access
Okay.
for today in Berlin.
Okay.
Okay, good. And what is the sample?
The ones I choose to compare.
And how did you choose them?
I choose them related to the distance and the price efficiency.
Okay, so you have limited yourself by some conditions from the beginning.
Yes.
Okay, and this should not be the situation while sampling,
Okay.
unless you have defined this in the population. So if the population is also limited by a certain space, I said Berlin, then you have to limit it to say it is 10, 11, 7. The Postleitzahl, the zip code 10, 11, 7. Okay? Then the sample should be a random abstraction of this population. So we will say I will take randomly samples of from the internet, from the available markets, and the prices. Okay, so here we have also a limitation that not all the markets in Berlin are on the internet. Okay, so this will affect. So this will affect again my question. The population, my population now will be the markets or the fish that they available in markets that they have also markets on the internet. Okay, so we are now biased. This is now the first introduction to the term biased, because the markets on the markets that have portals on the internet may have higher end prices or higher level of pricing than the normal ones. So you may be biased by thinking that this is the available and I will go and take this with that price. Okay? Sample should be representative of the population that I will take from. Okay? So if I would like to collect from the population of the people that they have, the markets that they have outlets here in Berlin, then I have to go to them and ask them for the prices. Okay? If I am looking for those who have portals on the internet and I can ask them through the internet, then I can go to the internet and start collecting the prices. Also, it may be affected by the if I collected the portal, the markets that they have phone numbers and I can call them. This is also this can introduce another bias to to my experiment or to the building of my sample. One of the very famous experiments, surveys that were conducted in USA was based on talking with the um, the citizens that they have right to vote through the phone and ask them for their opinions about certain question. And the problem is that they limited that this was at certain time, and when they have done this, they limited themselves with the people that they have phones at their homes, because not all the people have, and at that time it was a certain sector of the population that were able to get phones in their homes. Okay, so take care while designing the sample that you will use for your experiment, that to be representative, and check if any factor that your introduction that will happen during your access to the sample will affect or will act as a confounder. So now it is the term confounder that you need to take care of. The confounder is the phone confounder of the sample that I will access. Will it act as a factor that can affect the result? And what is... So, just a second. Okay. Another term that we need to take care of is the big categories of statistics. The first thing we need when we start our reporting our experiments, we divide them usually into descriptive and inferential statistics. Descriptive statistics to describe the sample that we have, describe the patients, and build a benchmark that we start from. So we describe, for example, the age of patients, the gender, how much patients at certain categories of this disease, is the staging, for example, the stage of patients in each category, and the levels of hormones, if we have something like this, the baseline of the experiment, or the baseline of the patients at the start of the experiment. And then the inferential is either to say if the results of my experiment in my sample how it will represent the bigger population. Okay, so if we take here our sample, either the fish market or the flower market, then we have to say how we conducted or how we have done this sampling to reach so the results will be also valid when we take it to the population and repeat the experiment again. Okay, so inferential statistics has a meaning of how if I take this sample from this population, then if I conduct this experiment, it will act here, and if I take it to the population, I infer that this will happen again. Okay, so this is the inferential statistics. Or it will happen again in the future if we take this experiment and make it on either another population or another bigger sample. Okay, so this is inferential. we have talked about the variable versus constant. The variables are the elements that will affect our experiment. Okay, I will use them as factors to check if they are affecting the outcome. The constant is something that will be stable all over the experiment, so I will not use it I will not consider it, but it will appear as a stable element all over the experiment. Anyhow, we will see this later during the practical work. And the variable itself has also two important elements. The first important element is a conceptual definition of the variable. When we start an experiment, we have to define each variable. So what is meant by, we have mentioned this last time, what is meant by heart rate, for example? How we will measure the heart rate. Or what is the definition of arrhythmia? Is the arrhythmia is something that is that will be associated with tachycardia or not will be associated with tachycardia? How big should be the bradycardia to be considered an arrhythmia, for example? And also an operational definition. So the data collection person should be able to collect in, for example, is it meters or centimeters that we will collect in? Is it day, month, year or month, day, year? Okay, so all these definitions should be also defined when I start data collection. Also, for a variable to be to start collecting, we need to define or we need it to be exhaustive and exclusive. For example, we are collecting the flower dataset. Okay, we have to collect all the options that are related to certain variable. For example, if we are having red and if we having the color as a variable, then all the colors should be mentioned. So if our study is interested about the red versus white, okay, so our study, our data collection form should include red, white, and then an option that the data collection person can choose for others. So either to write others, to have an option called others, so he will not be confused if there is a color called or to measure or to report rows as red or others. He should be also oriented by this point. Sitting together with the research team and saying, are we collecting rows as red or as others, for example? So everything should be clear and all the variables should be exhaustive. Should be there should be no options to be confusing. Okay? And also every variable should be exclusive for this aim. So we cannot say red and with odor, for example. So something like this should be two variables, should be divided into two variables. If it has odor and has a color, we cannot. This is our preference usually to give to insert the data into single variable. Okay, so collect color in a variable and the odor in another variable. The other term that I want to introduce you to is the independent versus dependent variable. The independent variable is something related to all the factors that are affecting the outcome. Okay? And the dependent variable is the outcome itself. Okay? Give me an example.
Third time.
Hmm?
The independent.
The
it's
independent
related.
and the dependent
Independent is related.
is
The independent variable is related to the other variables. Or
actually we should examine if the independent variables are related to each other to avoid any bias, because when we start collecting data we should take care that the independent variables should be not related to each other. Okay?
Okay.
So what's give me an example of independent variable.
Color and odor.
Is it are they independent? I don't know. I'm not expert in the field. Okay.
I think, yeah, not all.
But
the-
what is the dependent? In this case,
I think I don't know. There isn't. What's in it?
the price. Okay. So you assume that the price is dependent on the color and the. Okay. So this can be yes a nice comparison. So or
Example.
correlation. So we have color and odor against price.
Mhm.
Okay. And in your experiment?
My experiment. Independent. Okay. Independent is the type and weight, and the dependent is the price, I think.
Okay. So it is almost the same.
The same example.
The same example. Okay. Can the dependent or can one of the independent be dependence sometimes?
There is bias.
Can the dependent be independent?
Yeah.
The independent be dependent, or the other, or the it's okay.
Either sides.
In my example, I don't think so.
Okay. Give me another example. If we are having an experiment that is measuring specific effect of certain food type on the hypertension.
Effective food type and the hypertension.
Okay.
The hypertension.
What can be the dependent?
The dependent is the blood pressure values are the dependent value.
The dependent, the result. Okay.
And the independent is the food type.
Okay.
And the other way, we can expect the food type from the blood pressure values, perhaps. If someone have a higher blood pressure, could have this food type, perhaps.
Okay. We can also expect. We can say that the hypertension is affected by, for example, the cholesterol. Okay, and so the cholesterol can be either the independent of the independent of the blood pressure or dependent of the full type.
Mhm.
Full type. Okay, so it can these things can be also related to the question you are asking.
Mhm.
Are you asking about this on an interim milestone. So, for example, the cholesterol can be the interim variable or surrogate outcome. So it can be an independent for the blood pressure. We have mentioned this before, right? We have mentioned the surrogate outcomes.
Yes.
Surrogate outcome is outcome that is intermediary before development of a final outcome.
Okay.
So you don't need to wait till the development of final outcome, and you can measure it in the middle of the experiment. Okay. Surrogate outcome can be a dependent based on the factors I've assumed they develop or the.
We are looking for
Mhm.
our team. We are looking for the dependent.
Yeah, and it can be at other studies
Independent.
independent for the final outcome.
Okay.
Okay. We have discussed also the levels of measurement. So we have discussed the categorical variables and the or we call them also qualitative variables, and we have discussed the metric. We have discussed the metric variables or the quantitative variables. Right?
Metric and quantitative or the
Yeah, we have called them before categorical,
yeah.
and just introducing the other term, the qualitative, and metric, and the other term is quantitative.
Metric is quantitative. Or?
Yeah.
Okay.
And we discussed the nominal variable, right? We said we have categorical variables that are not, or that they assume they do not follow an order. Categorical, like any, like the hair color, for example, it is categorical,
Yeah.
and we cannot order them based on specific order.
Yeah.
And there is ordinal fields that should follow certain order. For example,
The colors too.
color can follow certain order.
From hill to
Okay. Okay. So dark to
dark,
bright.
or-
Okay. If you take it like this, yes. And this also is something you tell us why we call it levels of measurement. So when you said level of color brightness can be considered an ordinal, you have described the color based on certain criteria, and we have gained much information from your variable more than the color itself. Okay, so or by attaching both variables, the density of the color and the color itself, we can get more information. Okay, so levels of measurement. We have the least one is nominal. If the nominal is two levels, we call it. We have mentioned this also last time, or not the last one, but before. If it is two levels, we call it binary.
Binary.
Okay, so a categorical of two levels is binary. More it is categorical or nominal, and if the levels follow specific order, then it is ordinal. Or sometimes they call the binary, they call it dichotomous. Okay. Then we'll go to more. We call it not saturation, but resolution, to a higher resolution. So we go to the continuous and discrete. The metric, we have the continuous that can be divided into smaller units and infinite smaller units. Okay, like the distance can be defined into can be defined as millimeters and pico and nano and so on, or discrete that also have milestones. So we can say that temperature, for example, in some experiments we can say the temperature cannot be divided in a smaller unit, so we have 37, 38 and so on, or we can say that the scale of this experiment is from 1 to 10 and it cannot be divided into smaller units. Okay, so this can be.
It was me.
Okay. And when we collect data for categorical or ordinal data, we usually code the data. This is an important behavior while doing data collection, is to code the data giving each category a number. So when somebody collects the data for you, they will be, or he, she will be consistent while writing this data later on. Before the electronic forms, we usually had a case report form, as we mentioned last time, a case report form that either you should know by heart the category number for each category. So this male means 1, female means 2, for example, and then you write 1 or 2, or some case report form had the option to have 1 equals male, and then you encircle, for example, male. But in electronic forms, as you have seen last time on REDCap, you can electronically code each category from the beginning. Then you don't need to remember any coding later, because everything will happen behind the scenes. Okay, now we will open examples for publications, and we will check how the authors reported the results in the publications. Can you enter the website, the course website? You will find at the end of the module 2, you will find publications to examine. And you will find 5 publications.
Publication to examine. What should we do?
just look at the results section and just write your notes how they describe the data just in a notepad. Okay.
All 5 applications? Or just one? All
Yeah,
five?
yeah. This is a very small. You just describe the behavior of the authors.
How did they describe the data?
In the result section or in the...
Just the results. Yeah. Once you finish, just let me know. Okay. This just a brief description, not.
No, I don't, but I don't... What should we describe?
how did they present the data? Tables, figures? What are what are in the tables?
Mm-hmm.
Okay.
Okay. Tables, figures, percentage.
It's quantitative discrete values. like
Mm,
this.
yeah, but like, is it throw or is it processed, for example? Okay.
Mm-hmm.
Why do you think they have done this?
All of them are represented in the same way, I guess.
Mm-hmm.
All of them are represented in the same way.
Are you sure? Okay, shall we start?
That's my answer.
Choose one. Let me choose, or choose any one of them, and
Um,
I just need to present it here.
Your publication of 2017.
17.
Mm-hmm.
Sorry, the internet is very fast. So. Okay, the neonates with cancer.
Mm-hmm. So, in the results, first you mentioned the number of neonates who were included in the study, and then you quantified the number of diagnosed patients at 2 months and 3 months. And then you identified which diagnosis they had.
Okay.
And so all of this data is just quantitative and discrete. And
It was presented in numbers.
it was presented in numbers, yes.
Mm.
And then you gathered all of the data and you described it or represented it in a table with the group of the tumor and the gender of the patient, the race, and everything, the frequency.
So, it is
No, it's not of the patients, it's like a general grouping of neonatal cancers.
okay. And what else?
You also represented some data in graphs.
What are these data?
The survival of neonatal patients and older patients.
What is the survival?
The time from being diagnosed until the time of death.
It is okay. It is a probability.
Is the
Probability of being alive at certain time point after diagnosis.
And then another table with the overall survival of patients with graphs again.
Okay, but here it is not frequency. Okay.
Here is the overall survival.
Mm-hmm.
You mentioned.
And what is the third table?
The third table, the proportion of patients who died.
Okay, do you know another term of this table? This is what we call a contingency table.
What does it mean?
Contingency table. Contingency table means you are comparing proportions, and then you can either conduct another statistical test on it. So what we have done here is a chi-square test, but you can conduct also other types of tests.
Okay.
Okay. So here we presented the numbers of patients in each group. The best way of presenting data is to present usually the raw data beside the processed statistic. So if you will mention percentage, then please mention beside it the number, because the percentage can be very nice, representing 40 to 60%, and all the data that you have collected is 10 patients, 4 to 6, and this is meaningless. In matters of real life data, when you compare 4 to 6 patients against 4,000 to 6,000, it is more meaningful that this result is found in thousands terms, not in 4 to 6 persons. Do you understand? When you repeat things to a level of thousands, it is more, meaningful to show the strength of your data. Okay, and this is what we have done here. We have shown that yes, there can be important numbers, high risk in certain categories, but there are very small patients in these categories. So anybody who is taking this result should take care that this result is based on a small number, and also another good numbers or high statistical significant results, but with larger number of patients, and this should be taken with more confidence. Okay. So while presenting the data, try to include also the raw data in some form. Okay. We found that this is the most suitable form that we can represent our data in. And then in figure 1, we have mentioned in this figure, we have mentioned the survival curves, or we are presenting the survival curves. Also, we tried again, if you can zoom in, our curve within the graph itself. So you can see here, you can see the number of patients. The number of patients in each curve, so you can get if the difference between this curve and this curve is based on large patient population or patient sample, and you can find the statistical test here. So this is the log rank test is a test that compare between the survival curves. So here it was very significant p-value, and here too it was very significant, and it was based on large number of patients. Okay. The same for all graphs. We tried to describe the number of patients in each graph and the difference between the curves in each graph. So this is one of the methods. We call this the frequency, the sample frequency, and also you can include the relative frequency, which is the we call it the percentages. Okay, and sometimes we also include the cumulative frequency. The cumulative frequency allow us to see the percentages of each category and the categories below it. So you can get how much percent of these patients and all the patients in the above category. I mean, if you are ordering them, you will understand how much is the total in the previous categories and the next categories. So it is easier representation sometimes. And can you open, for example, what else have you opened?
Suicidal death within a year of cancer diagnosis.
Suicidal death, this is 2019.
2019 summit.
Okay, it is still downloading. Can you open Zikri 2020?
Outcome of childhood democracy.
Okay, what is the presentation of the data in this paper?
Represented the number and it's two in percentage.
Sorry?
The numbers in percentage, how much of the outcome. The first table. It's a categorized result. The table one.
Classified according to the clinical characteristics and demographic information of the patients.
Okay, the paper just presented the percentages, no more than that. In the first table, only the groups in the patients groups, and stages, number of cycles they have taken, and very simple presentation. And also table 2 had the same issue, surgical details presentation. Again, figure 3 is describing the survival. And that's it. This is the paper. It was very straightforward presentation of the data, of retrospective data, for a group of patients that we treated before. The point is, if you open supplementary table, I would suggest that you open supplementary table 1. Can you find supplementary table 1?
Figures and data.
Mm-hmm. So instead of describing or even summarizing the data into percentages, we have given a complete list of the patients. Okay, and we believe that for such small sample size, you should be also transparent with the reader and show all the details of the patients in your study. So here there were 18 patients. Everything is mentioned about the patients in this supplemental table 1. Supplemental table 2 included the pathological details of these patients, and that's it. The author can, the reader can come to the paper and do any statistics he think about. So this should be enough, or this should be enough for the small sample studies. Okay, just to mention the complete, a table with the complete data of all patients, and then percentages of each category. Each level within each category, each variable. Okay, it is not that hard to do that. Okay, and this is what we call a listed data table. So listed data table is what you have seen now. Sample frequency you have seen already, relative frequency with the percentages, and cumulative frequency is also the same like relative frequency, but with an addition of the previous or the next till it reached 100% cumulative frequency. And for each data type, either categorical we have a method of presentation, either numeric representation or graphic representation. Numeric representation, we have the listed in the categorical form, we have listed data tables, stamping frequency, relative frequency, and cumulative frequency. Or in continuous data types or levels, we can present them in mean, mood, median, and range. I believe if you gone through the courses, the data camp courses, you know by now what is meant by mean, mood, median, and range. So, what is mood?
The highest number
Repeated, okay. And what is median?
the number in the middle.
Middle, right. And what is range?
So from
Yeah, from.
values was
From two.
Okay, and what's the mean?
the average of them.
The arithmetic.
Whole by the number.
Yeah, the total over the. This is the arithmetic mean. And graphically, we represent the data in bar charts or pie charts if they are categorical. And as continuous, we represent the data as histogram or box plots. Yeah, so this should be one of the online courses you have to take over the camp. This was for univariate. Now for multivariate descriptive. When we describe that we have said for single variable, univariate variable, to describe use categorical variable, you mention the frequency. Okay, this is very simple. But what if two frequencies I want to compare to each other? Then I will have to describe them in what we call contingency tables. Okay, so the table we have seen, 2 by 2 table or more by more, I mean two more categories, by more categories than 2, then also you can compare them in cross tabulation. Okay. Also, like we have seen in the publication, for example, so this is a contingency table, 2 by 2, and here are also other a few. So here, this is more, I mean, multiple categories by multiple categories at different levels. Okay, so this is what we call also cross tabulation. Scatter plot is a graphical form of presenting data for discrete or continuous, and also we can represent them in correlation. So you know the scatter plot is a dot plot, and a correlation can show us a line representation of a correlation between two variables, two continuous variables.
Between the dots.
Mm-hmm.
Between the dots, correlation between the dots. Or
Between actually it assumes that they are continuous, so it connects the correlation plot, connect the dots together or build a relation of such assumption.
Okay.
Okay. Then there are mix of all these things. For the statistical tests, we have also another term called parametric versus non-parametric tests. What is meant by that? as yeah, so if you have taken the videos, you will know that some tests assume that there is normal distribution inside the sample that you have. Okay, so a parametric test assumes that there is a normal distribution, so you can take, you can apply this test on your sample if you are sure that that is normally distributed. And to make sure that sample is normally distributed, you have to conduct certain tests on it. The non-parametric tests are other tests that do not have such assumption, but it needs to sacrifice some of the some of the value of the data. So you will understand this once you pass the videos. So make sure, the point of this slide is to make sure that you know that some tests assume such statistical or normal distribution within the data. So make sure that you read the assumption of the test you will apply before using it. Every test has an assumption, so you can go to the internet and look for the assumption of this test. Assumption, for example, for a t-test. Here, it describes what is a t-test, and then it says that the t-test assumption concern the scale of measurement. The first, that the scale of measurement applied to the data follows a continuous or ordinal scale. So the first thing is that the data is continuous or ordinal. So don't apply it to categorical, okay? So here an example is the score of IQ test. The second assumption is that simple random sample. So the data are randomly selected from a total population. So if they are not randomly selected, if you have collected the data based on certain criteria, then you cannot apply this test to this sample. The third assumption that when plotted results in normal distribution. So take care, if the data is not normally distributed, then you should use an alternative for a t-test. Okay, so if you read a paper and read that the authors of this paper have used a t-test as to compare the means of the groups. For example, the mean age. They used the t-test to compare mean age between two groups. Okay? Then you have to ask the authors, are the sample sites in this study were normally distributed to conduct this test? Okay, this is an ABC in statistics.
Okay.
So take care that you don't apply a t-test a test that does not or that requires a normal distribution on a sample that is not normally distributed. So here, take care. This test requires a normal distribution. A sample that follows normal distribution. If it is not, Then search again for an alternative that you can write here. What is the alternative? T-test. Alternative t-test, non-parametric. And then you will find answers to that. So non-parametric alternative to t-test Welsh sample to test that Welsh two sample t-test. And here he used also Wilcoxon t-test. Okay? What I'm doing? Okay, so he used another test called Wilcoxon or Wilcox in his test as a non-parametric test. Okay? So this is usually the alternative. Another workaround that people use when they have a non-normally distributed data is to convert it to normally distributed data. And I don't encourage this, but sometimes it is the only way for doing statistics on some samples. Okay, there is a theory that if you if you go to the certain sample and you find it non-normally distributed, if you take enough samples of such sample, if you make multiple sampling of this not normally distributed sample, you will result in a normally distributed sample.
Normally distributed is randomized sample. Normally distributed sample.
Yeah, when you take random sampling or you make random sampling of non-normally distributed sample, at a certain time, at certain level, it will be converted into normally distributed sample.
Okay.
Okay, and
the normally distributed and non-normally distributed, you mean randomized, not randomized, or has another meaning?
normal distribution is this. Okay?
Yeah.
So it assumes that the population is distributed at around certain mean. Okay? This is the definition of normal distribution. There is a mean of this population, and the half of the population is distributed or located on the right of this mean, and the other half is distributed on the other side of this mean. The another point is that also the standard deviation. So it says that 68% is located under the one standard deviation to the right, one standard deviation to the left. So another name of this graph is density graph or density function, because it by knowing the area under this curve, you know the probability of being at certain point of this curve. So here it is not only the number of people, I mean it is the probability of being here. So the probability of being here about one standard deviation to the right of, or to the left is 68%. 68, yeah, 68, 68% to be here.
So we make.
So this is what we call a normal distribution curve. A bell curve, bell-shaped curve. It has a mean. Half of the population is located to the right, half of the population is located to the left. Okay? And one standard deviation to the right, one standard deviation to the left is allocating 68% of the probability.
So we make at first of the whole population a normal distribution, and then we take our sample from it, or
The normal distribution is
or what? How we
an
use
assumption.
it? How we use it? Or,
How we use it.
yes, I.
Okay. If you, for example, went to all the students that are attending certain course at Charity.
Okay.
Okay, and you have collected their age groups, their age, and then you have plotted how many patients, how many students are each at each certain age. Okay, so here is, for example, 23, 24, 25, 26, 27, 28, and you will find that if you have taken enough number of students, then you should find them distributed in such a bell curve. Okay, if these students are deviated, I mean this curve is deviating to another side. This side, for example, is the more the students are to the left side, then we call it a right skewed curve. Okay, and if the curve is more dense on the right side, here for example, and then there is a tail on the left side, then we call it a left skewed curve. And in both curves we cannot apply the tests that assume normal distribution. Okay, so this is the assumption that we need for some tests, for the parametric test, to use. The point is why it is these tests are requiring this or assuming this, or why in such tests we have to stick to the normal distribution. Because these tests are based on such probability that I mentioned, that within one standard deviation on each side, you have, to single side it is 34%. That probability of a person is located here. Another one standard deviation adds 13.6. Okay, another standard deviation adds 2.1. And this is a standard in all normal distribution curves. Okay, so they assume that these percentages are standard, and using what we call a z-score, we can locate, or we can know the probability of, for example, knowing if I know the mean and standard deviation of the students that I have mentioned now, I can get the probability of having the age of any student in this group. So what's the probability, for example, of having a student at 35 or 22 or more, or 22 or less? Then it will be easier through the mean and standard, knowing the mean and standard deviation. Okay, if they follow the normal distribution.
But if it not follows, it's not a big deal. I mean, it's not our problem. It's not a study problem, or
What do you mean?
if the population do not follow a normal distribution, it's only a finding. Then you can apply these tests. If not, then you choose another test.
You will choose another test. It will give you another probability of and it will give you another measurement confidence criteria. Okay, and also this what we can use, but we have to mention also which test we have used and what is the either the confidence interval or.
But it does not affect the value of the study or something. No.
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 Statistics
It's
statistics give you probability,
okay.
so it is not that. I mean, it is
It's only a
not.
finding. What
Yeah.
we find, we deal with what we find.
Yeah, exactly. Okay, so you have installed R and installed RStudio.
Mhm.
Good. Then we can jump into that. الفكرة بس يعني الفكرة من النقطة ديت إن أنت تبقى عارف أنت هتستخدم أنهي تيست.
Yeah, yeah. Mhm.
خلاص؟
Mhm.
التيست اللي هتستخدمه بيبقى مبني على حتة إذا كان بارامتريك ولا نون بارامتريك. ماشي؟ الداتا يعني التيست هتستخدم نون بارامتريك تيست ولا بارامتريك تيست.
Okay.
الترم ده لازم تبقى عارفه.
Yeah.
كلمة بارامتريك وترم بتاع نون بارامتريك. دي النقطة الثانية النورمال ديستريبيوشن. هو يعني ايه بارامتريك؟ يعني follows or assumes normal distribution in the sample.
Mhm.
طيب السامبل عندي مش normally distributed خلاص؟
Mhm.
طيب هقدر استخدم الستاتستيكال تيست بتاعت النورمال ديستريبيوتد؟ اقدر، لكن لازم احولها لنورمال ديستريبيوتد سامبل. ازاي؟
أنا أعمل فيها randomization.
ان انا اخد منها راندوم سامبلنج. يعني ممكن يكون عندي مثلا 10 اشخاص
Yeah.
خلاص،
Mhm.
عن طريق ان انا بختار اوبشن مثلا ان هو حاجه اسمها بوت سترابنج. وانا بعمل statistical تيست في ساعات هتلاقي بعد كده حاجه اسمها بوت سترابنج. بوت سترابنج ده ان انت تاخد من السامبل الصغيره ديت مثلا اللي هي 10 تاخد منها 1000 سامبل،
Mhm.
تعمل منها سامبلنج 1000 مره، كل مره تاخد خمس اشخاص مثلا. خلاص، فلما تاخد 5 اشخاص من ال10 ممكن وتاخدهم 1000 مره، خلاص هيبني لك سامبل 5000 واحد.
Yeah.
خلاص ال 5000 واحد دولت هيبقوا نورمال ديستريبيوتد.
Okay.
ماشي؟
بس ده هيبقى شوية فيك يعني.
مش فيك ولا حاجه. انا كان جاي لي ستادي براجعها، برضو عملوا سامبلنج ل كانت هو ما كانش المشكله كان المشكله ان هم عندهم 100 عيان في الجروب خلاص، و2000 عيان في جروب تاني خلاص. فلا اما يكتر ال100 اللي في ناحيه يخليهم قد ال2000، لا اما يسامبل من ال2000 يخليهم قد ال100 او 200 اللي في الجروب التاني. فهو عمل الطريقتين، عمل سامبلنج من ال100 وكومبيرد بال2000، بقى كبرهم خلاهم 2000
Yeah.
ماشي، بحيث حتى لما يكبروا يبقوا نورمال ديستريبيوتد ويقدر يقارنهم بالجروب التاني.
Okay.
ماشي.
تمام.
ف يعني العاب في القصه دي.
Yeah.
اوكي.
بس قصدي دي حاجه مش في ايدينا احنا، يعني انا الواحد هو شاف البوبيوليشن بتاعته، البوبيوليشن دي تطلع نورمال ديستريبيوتد يا اما نوت نورمال ديستريبيوتد.
اللي بيحصل بالظبط انت ما تقدرش تغير في البوبيوليشن اللي انت شفتها. تمام.
اوكي.
لكن تقدر تعمل لا اما توسع السامبل بتاعتك. انت البوبيوليشن هيتروجينيتي هو اللي احنا بنتكلم فيه ده بيزد على البوبيوليشن هيتروجينيتي.
اوكي.
البوبيوليشن هيتروجينس هنعمل ايه؟ خلاص. فاللي انت بتعمله ممكن ان انت تكبر السامبل، فكل ما السامبل كبرت كل ما احتمال الهيتروجينيتي اقل. خلاص. وكل ما او ممكن انت بقى تعمل بقى بنفسك الموضوع السامبلينج، المالتيبل سامبلينج ده، فيحول لك النون او النوت نورمال ديستريبيوتد سامبل لنورمال ديستريبيوتد سامبل. اوكي. بس اوكي. طيب ناخد بريك.
وبعدين اشتغل على ارسل ولا؟
انا معايا داتا، ولو انتوا ممكن تشتغلوا على الداتا الصغنططه ديت بس.
مش هنعمل حاجه بالداتا بتاعت السمك
ما انا ايه؟
مش هنعمل حاجه بالداتا بتاعت السمك والورد؟
لا صغيره.
ما انا بقول هنبدا بيها وبعدين ممكن ممكن نشتغل على
ماشي. نروح نصلي دلوقتي. ناكل.
نصلي.
ناخدها على فلاش.
ظهر عندك اسمه ايه؟ كان في شيت كده باتش. ظهر عندك؟
الباتش؟ موجود على البروفايل.
اوكي تمام. اصل انا ما اعرفش شكله هيطلع ازاي بصراحه.
حضرتك عملت ديزاين؟
عمل له ديزاين. هو اصل في 2 اخذوا بادجات المره اللي فاتت.
مين؟
انتي اخدتي بادج على موضوع الاتندنس، ودكتوره فاطمه اخذت على موضوع داتا كام.
بس كده احنا الاثنين خدنا؟
بس
انا عملت 1000 اكسبيرينس بوينت مش عارف.
انا بقيت رقم 3 تقريبا او حاجه. بس هي دكتوره فاطمه مش بتحضر الاوفلاين، عندها وقت اونلاين.
هي فكره
فاطمه
بتسافر مرتين في الاسبوع 5 ساعات. عندها وقت كتير. اعرفها. فاطمه صبر.
هي بتشتغل في المانيا؟
فاطمه بتعمل ريسيرش.
ما شاء الله. لا سريع قوي يعني. خلصت 5 كورسات و25 شابتر.
عندها ساعتين.
ربع اللي انا خلصته في كام شهر. في الساعات ما شاء الله.
ما هي دكتور بيقول
هي فاطمه بتبقى في روستوك، بتروح روستوك يوم الاثنين من بليفل، فبتقعد 5 ساعات. بتقعد هناك في بليفل.